Okay, so I think my screen is visible, and yesterday we discussed about the multiplication concepts. Okay, so as we have discussed, three methods of multiplication. Three methods of multiplication. So one is Booth's multiplication using table method. Booth's multiplication using the table method. Okay, that is signed multiplication. Huh? So in this case, what is the initialization part? Okay, initialization. Okay, initialization of what? Initialization of. Is my screen visible? Yes, Nahina. Anyone unmute?
Yes, sir, visible.
Okay, thank. So multiplicand in B register. Okay, multiplicand and multiplier Q register. उसके बाद क्या है? ये accumulator initially 0, Q minus 1 initially 0. So that is about the initialization. So once we initialize, we compare Q naught, Q minus 1, and here there are four cases are there. If it is 0 1, Q naught and Q minus 1 0 1 रहा तो you have to perform the A plus B operation, and if it is 1 0 रहा तो A minus B operation. Okay, and here in this case, like if both are same, okay, if both are same, Q naught and Q minus 1 value, then add, not add, shift right, only shift right of what? Content of A, content of Q, and content of Q minus 1. Okay, only this much when both are same. यहाँ क्या करते हैं? A minus B. After that we go for the shift right. Here also we go for the shift right. Then check the count. If the count is not equal to 0, count is less than not equal to 0, it means count is greater than 0. Okay, then again we will process for the comparing. Okay, so this is about the table method. तो table method में हम क्या करते हैं? Content of A, no, not content of A, content of Q, content of Q minus 1. Okay, we used to represent, no, here like table form. Okay, so in that again we represent the A content, Q content, and Q minus 1. Okay, so initially like suppose if the multiplicand is, suppose 4 into 5, 4 is multiplicand. Okay, B register में क्या करते हैं? 4 is 4 and Q में क्या करते हैं? 5. 5 means 101. Suppose negative रहा तो you have to take the 2 complement. So here we will put 5, initially 0, and B is 4 bit means A is also 4 bit. Okay, so that is about the initialization. Okay, and next what we do? We compare. Initialization के बाद क्या करते हैं हम? We'll compare this Q naught and Q minus 1. So this is Q naught, Q1, Q2, Q3. This Q naught and Q minus 1 we will compare. If it is 1 0, 1 0 means क्या है? If it is 1 0, perform the A minus B operation, then perform the shift add right. Okay, that is about the this particular table method. Then after that, yesterday we discussed Booth recoded multiplier. Booth recoded multiplier. So here in this case, what we are doing? Suppose if it is a 14 into 5. Okay, so for this whatever the multiplier we will get, multiplier value, okay, we are recoded the multiplier value with the rules, right? With the rules, both recoded multiplier, okay. Can anyone tell what is the rules क्या था वो for both recoded multiplier? Here this is the multiplicand value, then multiplier value, and we have to recode that multiplier, this one, both recoded multiplier. So both recoded multiplier का क्या था वो? First case is that if we find first one in a string, first one, then write as a -1, and for next 0, it means next one, means same if we get after the 1, then write it as 0. And second rule is if we find the next 0, means 1 के बाद, if we find next 0, then write it as +1. Okay, means yeah, ऐसा है, for example 1 0 1 0 0 0 1 0. Okay, so first if we have to track for the 1, we have to scan the bit from the right to left. In this way we have to scan, and if we find the 1 in the string, then that we will replace with -1. Okay, and for the next 0, +1. Okay, first we have to track for the 1. ये ऐसा ही रहा तो इसको same as it is you write down 0, but first we have to track for the first one. If we get first one, that -1, उसके बाद next 0 आता है ना, उसका +1. And if we get the same digit, then 0 only. Again same रहा तो 0. And if we find the next one, then write it as -1. Next 0, +1. Next one, -1. Okay. So is there any doubt here? Yes, let me know any doubt. This is a recoded multiplier. We recode recoded multiplier, because that one more algorithm is there. No, what is that? Bit pair recoding. So in the bit pair recoding of Booth's algorithm, you have to go for this particular recoded. After that, we are going for the bit pair recoding. Okay. So in both recoded multiplier, we have some drawbacks. What is the drawback? यहाँ क्या करते हैं both recoded में? We'll take the multiplicand value. Okay. We'll take a multiplicand value and we'll solve this problem. Okay, multiplicand and the position. तो यहाँ क्या होता है? If there is a worst case, you will get more number of plus minus 1. So more number of plus 1 minus 1 operation means that much time you have to perform the steps, operations you have to perform. Okay, so here 1 2 3, there are 3 plus 1s are there and 3 minus 1. Okay, so total 6. 1 2 3, ये मल्टीप्लिकेशन करना पड़ेगा ना, 4 5 6. So total 6 steps are there, and it takes more time. It takes more time. Okay. So the next method is called as the bit pair recoding method. Okay. The next method is called as bit pair recoding method. Bit pair recoding or modified booth algorithm. Modified, we call it as modified booth algorithm. Modified booth algorithm. Okay. So here we are having the same again, multiplicand value is there. Okay, multiplicand value, multiplier value is there. Then after that we go with booth recoded multiplier. Okay, booth recoded में क्या होता है? If we find the 1, then we write it as -1. For the next 0, +1. For again 1, -1, 0, +1, again 1, -1, 0, +1. After this particular recoded multiplier, we form a pair. That only we can call it as bit pair recoding. Fourth step. Okay, we call it as bit pair recoding. So how this bit pair recoding? It is based upon this table. Okay, as yesterday we discussed, for 0, 0, 0, or means here you have to pair. For this particular pair, we are replacing this with this particular value. और 0 + 1 आया तो +1, 0 - 1 आया तो -1. Okay, then +1, 0 for this, +2, -1, 0, -2. You have to remember this table. Okay, +1, 0, +2, -1, 0, -2. Then one more case is that +1, -1. That is +1. या जो फर्स्ट कौन सा साइन है? +1, -1, +1, -1, +1, -1. Okay, these two cases are not coming. Means as per the rule, no, it won't come. +1, +1 नहीं आता at any condition. Okay, if we apply the both recoded, so initially 0 for next one तो -1, 0 +1, -1, and 0 +1. We won't get +1, +1 or -1, -1. Okay, we won't get this case. Okay, so this is about the here. So +1, -1 means +1, +1, -1. That particular this pair is replaced by this value, bit pair recoded multiplier. +1, -1 replaced by this one, bit pair recoded multiplier. Okay, then after that okay, +14. So actually in the particular previous problem we have taken 21 means multiplier. In this case here it is multiplier is there. 21 into 2 raised to 0 means 1. Then 21 into 2 raised to 0. Here it will start from the 2 raised to 2. Then here 21 into 2 raised to 2 raised to 2, 2 raised to 3, 2 raised to 4. This one 16. So 21 into 14 how much multiplication? 21 into 14. 294. Okay. So yeah, just I was confirming. So here in this modified Booth algorithm, or what is this method? Bit pair recoding algorithm. So here we use this particular multiplier value. Sorry, यहाँ गड़बड़ था. That's why I was confused about this. See here, while representing, no, actually क्या है, this particular binary here, mistake is there. This is for binary, this is for the 14. Okay, and this one is there, no, here 21 का है. This is 21, multiplier is 20. That's why I was getting confusion even yesterday was also. So here actually हम multiplicand ही लेते हैं. यहाँ मिस्टेक है थोड़ा, ये जो हम बाइनरी यहाँ actually it is at 14. Okay, so multiplicand it is there, multiplicand only we are taking, because यहाँ जो था ना, it is just one step extension है. यहाँ जो है, this is correct multiplicand value. Okay, both recorded multiplier में हम क्या कर रहे हैं, एक ही स्टेप ऐड कर रहे हैं. फर्स्ट स्टेप multiplicand multiplier, then recoded multiplier. Okay, उसके बाद जो फोर्थ स्टेप है ना, ये तीन स्टेप तो यहाँ भी है in this step. Okay, first step is multiplicand, second step is multiplier, and third step is both recoded, और ये फोर्थ स्टेप आ गया recoded में, bit pair recoded. So here actually यहाँ थोड़ा गड़बड़ था, so here the mistake is there. Yeah, is it clear? Yeah, even yesterday was also I was getting some confusion, but I was not observed carefully. Okay, so here see what 1110 means it is for the 14 only. यहाँ तो mistake हुआ थोड़ा. Okay, तो यहाँ क्या आना था? It is 14 decimal. Okay, यहाँ जो है this is the binary for 21. 21 का binary है. This is the first number, second number. और यहाँ क्या करते हैं हम? This is correct. Okay, this is correct. Okay, क्योंकि ऊपर का जो प्रॉब्लम है ना, the same problem we are कंटिन्यूइंग. यहाँ जस्ट एक ऐड होता है, बिट पेयर रिकॉर्डेड मल्टीप्लायर, बिट पेयर recoded multiplier. Okay, that is the only one thing where. Yes, let me know any doubt in this. Yes, any doubt? So total there are three methods are there for multiplication algorithm. Okay, then actually you will get one or two gate questions from this particular subject. Okay, especially on this data representation is there, no? Like you need to understand the concepts. See here, as we can solve the some of the problems. Okay, like converting the decimal number to signed representation. Okay, but once we while performing the opposite means this particular. Okay, I hope the screen is visible. Okay, यहाँ जो ये नंबर है single precision representation. The following bit pattern represent the IEEE 754 format. IEEE 754 means क्या है? Sign 1 bit, exponent 8 bit, then 20 bit for the mantis or the fraction. Okay, so that you have to represent in a decimal form. उल्टा आपने पहला क्या किया था? Okay, you are converted the -26 into binary. Okay, so now they are given like, so this is the digits they are given 1 1 2 3 4 5 5 times 0 1 1. So this is, and fraction part 1 and remaining 20 fraction 1 0. This is sign, this is exponent. Okay, this is the given their input. Okay, and you need to find out. So here the sign is given 1, the exponent part, and what is the bias we add actually in a exponent. एक्सपोनेंट पार्ट में हम क्या करते हैं रिप्रेजेंट करने के वक्त वी ऐड 127 टू दैट एक्सपोनेंट वैल्यू. ओके, we will perform the add operation. We will add 127 to the exponent. Okay, so we will add that time while converting decimal to that binary form. तो यहाँ क्या करना पड़ेगा? You have to subtract. हम रिवर्स कर रहे हैं. Okay, we have to subtract 127, so you will get a exponent value, right? Yeah, यहाँ क्या होता है 1 0, इसका डेसिमल कितना होता है 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 4 5 6 7. 7 means what? 128. तो कितना होगा 131. तो 131 minus 127 हम पहले ऐड करते थे ना. So now you will get 4. Exponent value will be 4, and this is the fraction part. Okay, तो ये ऐसा आएगा फिर 1.101 into 2 raised to 4. 1.101 into 2 raised to 4. Okay. Mentissa. And वो भी fraction इन्होंने ये निकाला है. So this binary is removed. 1 1 0 1 decimal point is removed. Okay. 1 1 0 1 0 1 1 0 1 0. So 0 1 2 3 3 means 8 4 24 26 and sign क्या है यहाँ negative, so it indicates minus 26. See, why I'm explaining this type of example, no? Okay, so actually you people will appear for the gate examination in the future. Okay, and gate examination is for like to get your high packages and to get any product based companies. Okay, so you will appear for the gate examination, so that's why this is a fixed question they will ask. Okay, so you should know how to, like, normally, no, in theory, while discussing in the theory section, like I discussed about minus 14.25. Convert this number to IEEE 754 single precision format. Single precision format. Okay. So we will get this. Okay, we will convert and we will represent in a 32-bit form. 32-bit format हम represent करते हैं. Okay. बट इसका जो उल्टा आपके गेट एग्जामिनेशन में कैसा आता है, इन द गेट एग्जामिनेशन यू विल गेट ए रिवर्स वे. They will give the data, that result, and they will tell you to find out this minus 26. वहाँ क्या करते हैं हम एक्सपोनेंट को बायस्ड वैल्यू ऐड करते हैं ना, 127 फॉर सिंगल प्रिसीजन, 1023 फॉर द 127 for single, 1023 for the double precision. Okay, यहाँ क्या करें, माइनस करना पड़ेगा. कहाँ, ये जो रिवर्स प्रोसेस में है, यहाँ यू आर सब्सट्रैक्टिंग टू गेट दैट एक्सपोनेंट वैल्यू. ओके, टू गेट दैट, यहाँ ऐसे to get this exponent value we are subtracting the 127 biased value. Okay, so like in a third year you are having some of the database subjects, operating system subjects. Okay, what are the subjects you are having this semester? Yes, roll number 58. Roll number 58. 23 8. Yes, Nain, are you there?
Yes, sir.
What are the subjects you are having this semester?
Sir, operating system,
Okay.
then system software,
Okay.
and design and analysis of algorithm,
Okay.
database engineering, and Python and COA.
Yes. See guys, all these subjects are very important. Okay, COA, system software, database engineering. Okay, Python is, it is required. It is by default. It is required for your coding and operating system. Okay, so these are all subjects that is core subjects are there. These are the core subjects, and for GATE, almost you will get around 10 to 15 questions from these subjects. So now, if you like in the your third year, in the third year, second semester, next year you can appear for the GATE examination. Third year is also eligible. So one advantage for the GATE is like you can get into some product based company, and product based means like the package, like these service based companies are there, no, like service based companies or whatever comes in the campus that pays around 3.5 to 5 LPA. So if you go to product based company, so it is more than, okay, more than more than 5 LPA. Okay, more than 5 LPA you will get. Means it is, I'm just telling you some simple simple example. And one more thing is that now you are in a third year, and suppose if you go through the gate to some IITs and NITs, you can try for your higher education, MTech. Okay, so no, and some top triple IITs. Okay, triple IITs are also there, Central University. So if you get the MTech in MTech master, okay, so where the placement opportunity you will get, placement opportunity, that is minimum you will get 15 LPA minimum, 15 onwards. Okay, just simple example, like suppose A person is there and a B person. A person after the B or BTech, okay, A person he will join to some XYZ company, okay, and B will join to MTech, ME or MTech course. एक कंपनी को ज्वाइन करेगा, एमई एमटेक को यहाँ एक टॉप कॉलेजेस में ज्वाइन करेगा बी. Okay, I hope you are getting. Okay, so your pass out is 21 22, right? 22 23. Your B will complete in 22 23 batch. Okay, A person is joining to company, B person is joining to MTech. So during the 2023, A is getting a salary around 5 LPA. Okay. In 2023, B is studying. Okay. In 2024, A is getting around 6 LPA. It's all increment 1 lakh. 2024, this guy he will get an internship second year in campus only. He will get an internship with around 5 to 6 LPA. Okay, 1 year as an intern if he will get, तो उसका अर्निंग स्टार्ट हो जाएगा. In 2025, he may reached 7.5 LPA, but in 2025, he will get placed in some company with 15 to 20 LPA minimum. Okay, so you people just think about it. Okay, so I'm not just saying like this is the scenario. Most of the people like they want immediate like job. If you are having some financial and all for to lead your And if you have any financial problem and all, you can go with this. But you can even like it is only with one year only you will face here without job. But from the next 2 years you will start your earnings. But here to get into this, it is not an easy. Means easy means you have to do a preparation like a gate examination. You do a hard work. You put a effort for this gate preparation so that you get some top college, and anyone can get it. Huh? It is not like if you work, if you have a goal, okay, if you want to get success, then you have to put effort and you have to start preparation for this gate examination. And this semester in your as per your academic, it covers around 6 subjects. No, 6 subjects you are covering here. So in this particular 6 subject, you will minimum you will get 10 to 15 marks easily. You will get. Okay, and general category का कितना था मालूम कट ऑफ around 23 to 25 marks. Okay, and to get so at least you should get a top rank. Okay, for that now only you have to start. Not only qualifying, you have to come within the at least 1500 ranking. Okay, so but it comes with a dedication, with dedicatedly if you work, if you solve the previous year questions and all, that you can achieve because your time is there. No, आपका you are appearing for like आपका graduation खत्म होता है 2023, right? 2023 June. Okay, 2021 में आपका थर्ड ईयर है, 2022 में your फाइनल ईयर विल स्टार्ट नो. तो 2023 जून में आपका ये खत्म होता है बी. So and these even to in campus in the placement you can to for the job security you can appear and you can get it in any company. Okay, definitely you can get it. You can get it in your placement. You will get easily this placement. You will get no need to worry. But if possible, if you have a goal, then you can try for the gate also. So like for this particular such type of tricky questions we'll ask. Normally we in the theory class and all we solve the one way. Okay, but in gate they ask reverse. Most of the questions. This is the in this particular file. No, I have collected some gate questions. So here also you can see I3 7.4 floating point data is there. They are given two registers and they stored some values. Okay, they stored some values. If R3 is equal to R1 by 2, what is the value stored in the R3? R1 by R2, then what is the value stored? Means they are stored some value already in the two registers and the division. Okay, means it is also reverse way. They are asked a reverse way. And there is one more example. Almost for most of the examples, no, they asked because normally we think in a normal way, like to decimal to binary. Okay, यहाँ भी देखो given the binary 32 उन्होंने ये दिया है क्या that is result and you need to find out this one 2.27, that is your answer. Means actually normally हम in the examination and all I tell you to like convert this number into binary. Okay, binary single precision format, right? So you have to convert this into single precision. But यहाँ कैसा है उल्टा दिया है उन्होंने रिजल्ट ही दिया है and that you have to convert into this form. Okay, like here we have to subtract in the exponent. The exponent actually 124 है, उसमें 127 माइनस करो तो माइनस आता है, so that is 2 raised to minus 3. Okay, 2 raised to minus 3, and that Mantissa part is there. So Mantissa part, where we are getting 1.847 into 2 raised to minus 3. Okay, so in this way you have to solve it. Practice चाहिए थोड़ा. If you do some practice, no, then only you can do it. Okay, so now in your Google Classroom, okay, so I will give you one assignment.